So hello everyone, welcome back to my channel and happy 2022. So much has changed since I published my video to review my first year studying experience at UChicago MSCA program. So to kind of quickly recap from my first year review, I went through a bunch of classes that I took, my work fellowships, and also some of the school programs or work experience. So after my first year, I complete a summer data science internship in remote basis. So please refer to my video talking about my exciting summer internship experience and how did I get a full-time job offer. In this video, I'm going to do my review on my second year study at UChicago MSCA program as a graduate student. As usual, I was working full-time and taking classes part-time. After my summer internship, I started a full-time position in ads and marketing agency in their data analytic department to working on their marketing science project. So after staying there for like several months, I then jumped to work for one of the biggest consulting firm working as a data scientist while I took on a full stack data science project there. So if you want to know more about that experience, please check out my experience working as a data scientist at the consulting firm in this video down below. At the same time, I started my Capstone project with an Singaporean-based education startup tech company. If you're interested in hearing more about my reviews regarding to my graduation Capstone project, please check out my video to review my Capstone project. So let's dive into my review on my second year school at MSCA program. During my second year, I decided to postpone my graduation to the fall 2022 so I could have more time focusing on my Capstone project, my jobs, and a lot of life event stuff going on. To be honest, like 2020, 2021 are the best year that it's just for everything to go smoothly to me. But like after I hit 2022, like reality kicks in and a lot of like frustrating life event stuff start to burn me out. So I have to juggle between a lot of personal stuff with school stuff with the job. So it was like kind of like a tough year for me. So I decided to kind of postpone my graduation. Also in terms of classes, I was able to complete like 7 credited classes, including required core classes and then electives. And 1 seminar non-credit classes. This first part of my review video, I will mainly review all the classes that I took to help you to scoop on why are they useful, what did I get out of those classes, and apply those skills that I learned from the classroom into my daily jobs. So in part 2 and part 3 video, I will also talk about my job hunting experiences that I went through before my graduation. So I will cover the changes of the employment job market due to, at the beginning, like great resignation during pandemics to quiet quitting trend like post-pandemics to this recent massive layoff situation due to inflation, instability of the world financial system, and the recession. I'll also touch on my burnout issues during my second years as I gone through many things like including classes, schooling, projects, jobs, life events, and so on from 2021 to 2022 moving forward. So finally, at the end of my review on my second year, I will also review what's going to be next, like where am I going right on the edge of my graduation, where I will be heading to in terms of my career tracks and so on. Next, I will kind of review and talk about those classes and point out something that useful about those classes that can serve as like a, helpful references for you to select your own courses. Time series is like one of the required core class. It is like a very challenging class as it is very quantitative driven and very concept driven. It covers techniques on how to approach and model problems that involves time changes as the main independent factor. So in detail, this course mainly covers like a different time series modeling techniques within R, and this class touch on concept from the simplest such as how to deal with time series driven attribute transformation with techniques such as like exponential smoothing, time series regressions, how can you look for trends and seasonalities and so on, and then also touch on the concept what is autocorrelation, which is one of the most important concepts within time series forecasting. This class also covers more advanced models such as ARIMA, seasonal RIMA, spectral analysis, like GARCH, Bayesian time series model. Then finally, we combine the case studies and homeworks from a project within this class to kind of help students to practice on time series modeling, selections, performance evaluations for driving insights and driving patterns from our data when it comes to forecasting along with the time. This course was very helpful for many real work applications such as like in finance, retail, supply chain, and anything that requires time as the most important factors. While I was working for this marketing agency, so I was assigned to work on a time series project for a retail client. So I was literally learning about regression with a Riemann error model from the class on one night, and then I took it and apply it directly into my real work project the next day. I was able to kind of extract many significant time series hidden correlations, insights between clients, US retail stores footfall data versus their sales fluctuation during pandemics. Data engineering is probably one of the most useful classes for any students who want to break into data science, data analytics, or anything within data, as it is the most fundamental skills in any data-driven job. So MSCA students usually take this class in their first school quarter, but I wanted to take it as a reviewing purposes, as this covers basic SQL databases and some useful data manipulation skills. They also cover some data reporting and visualization technique. This class also touches on analytic infrastructures and frameworks, like what is BI's data infrastructure like? Why is different from a machine learning team's data infrastructure? Those concepts are quite useful when it comes to understanding the enterprise level of the analytic world for different companies and different business world. The skills such as MongoDB and Neo4j can be great skills that you can put in your resume, and then I can see those skills are getting more and more necessary and relevant as our data science grows. In terms of the workload for this class, it can be pretty heavy. There are lots of homeworks, projects they're doable, but they take a lot of time and energy to complete, and you kind of have to study for it. Even though I already know this stuff, I still kind of have to take my time to do the homework and complete whatever is required to pass the class. In terms of application, as a former data engineer and a BI engineer, and currently a data scientist, who perform tons of data engineering day to day, this class is like a bread and butter for your daily job in this field. If you don't have any data engineering skill, this class is probably more important than the fact that you know what neural network is. You're not guaranteed to use neural network, but you're guaranteed to use data engineering skills in any of the data related job. Machine learning and advanced predictive analytics class is more advanced core class. It can be quite challenging as this class captures and teaches you some of the very abstract machine learning concepts, which currently everything was wrapped up more in Python or R's machine learning related libraries. There's some overlaps between machine learning and the data mining classes, but what differs them are that if data mining class teaches you how to apply different fundamental and useful mathematical driven techniques to help you to model your data and drive useful insight and do some prediction in the pretty day-to-day situation, machine learning class will be more focused on the underlying framework concept of different genres of models such as optimization, trees, support vectors, neural networks, and so on. This class is kind of like a machine learning and AI bootcamp that touches students to many things that could be kind of overwhelming. But there are three key takeaways for me from these classes. First of all, on top of the data mining stuff, through machine learning classes, I was able to learn more fundamental machine learning optimization and state-of-art techniques in more detail, such as regularization, gradient descent, bagging, boosting techniques. What are those algorithms I really like step by step, or sample learning, kernel tricks, and etc. Secondly, my biggest takeaway was learning how to recognize and tune the parameters or hyperparameters of different machine learning models that got imported from your Python library, which is very convenient, but the more important thing is for you to know what those hyperparameter means and how can you make it better to make your model more accurate, more precise, whatever application that you're driving to solve your problem. Thirdly, my biggest takeaway from this class is this class gave me a general understanding of what deep learning is. There's different type of neural networks and what are the fundamental techniques that contribute to why neural networks can be so powerful to model for any shape of data. For real-world application prospect, this machine learning and advanced analytic class also helped me to do my data science job at the consulting firm. Even though I did not end up implementing a very advanced model like neural networks to approach my problems during my actual work, machine learning class definitely helped me to approach prediction problems with more systematic way that reinforced myself to follow the best practice on creating my own model frameworks, evaluating performances, tuning the model, building key components of modeling pipelines to ensure optimization of the predicted results as much as I can as a data scientist. And the machine learning classes also better prepare you to work on your capstone project, which sometimes so many students will try to implement this very complicated machine learning models to approach your problem. And this class will definitely give you that toolkit and a general understanding of those situations. Deep Learning and Image Processing Seminar. So this class is not credited class when I was taking it, but I know this class has been recently converted into actual credit class to be one of the elective that you can take instead of a seminar. Seminar is definitely cheaper and less overwhelming in terms like the workload that you can take on, but it is definitely not credited, and it's more like something you pay for and then it give you some knowledges about deep learning and image processing. So I took this seminar with the required core class machine learning and advanced analytics. It served as a great complement on the knowledge I was learning through machine learning class. And there are some duplicated knowledges for sure you can get from machine learning course and through this course at the same time. From what I see, it is nice to learn the granularities of machine learning and deep learning twice, I'll say. What differs the seminar class from the machine learning class is that you put way more weight on learning about image data preparations of pixels. You get to apply this advanced deep learning and neural network technique specific for image processing or computer vision. But I feel like as an entry-level analytic professional, I recommend you to take this class when you're extremely interested in computer vision or when you have more understanding what is neural network, what is deep learning, you have more experience in modeling with neural networks already. But most of the analytic job out there does not require this kind of skills. So the trade-off would be your time that's spent on this class without actually helping you prep for some of the more generic data science interviews. But of course, unless you're breaking into more heavy machine learning, engineering, and deep learning, software engineer, AI automation type of job, this class could be very useful because it gave you the fundamentals on what computer vision is. And it would be a great seminar class to take. But right now, it's probably a good elective they can take. NLP is one of the hottest and one of the most challenging fields of study in data science. I took this class because I wanted to continue what I did with my capstone. As my capstone project requires using NLP techniques and models to measure video speech content qualities. So it would be nice for me to learn it more systematically from my class and gain more comprehensive intuitions about how to deal with text and language data in the future. I used what I learned from my NLP class to implement in my capstone classes project to better extract and segment speech sentences, recognize and divide sentences from video contents. So this class also touched on how to engineer text-driven data and how to label and give meanings to different texts or sentences. For example, in a real-world application, like a law firm can take lots of legal claims, text data or documentations to model for how likely this lawsuit can succeed and could give a better estimate how much money this lawsuit will get involved for companies or for individuals. NLP class also touches on hot sentimental analysis, which covers the attitude of from social medias on certain topics to drive marketing, sales, finance, or economic insights. So from a modeling concept perspective, student will be learning how to classify text, extract topics, create bots, search engines such as using BERT, Albert, and many other different basic or advanced tokenization or vectorization techniques to help us to mine that deeper semantics or meanings within our language application. This class is overall not that chill, but is doable, that we're not required to form a group or working any group settings for the homeworks or projects. Everything is individual level. So if you want to team up with other students, this class may be not for you. This class have to be a little bit more self-driven, but Professor Nick kind of planned many engagement activities within the class for us to think and learn during the class, which are something nice to have. So algorithmic marketing class covers a wide range of marketing concepts, and then they're modeled by statistical and machine learning techniques to help data scientists to drive inferences and prediction decisions. It covers from like customer segmentations, retails assortment, pricing, product design creations, running marketing campaigns, getting to know what consumer is, and optimization for those business settings. Those concepts are widely adopted by companies such as big consulting firms, RI Nelson, or any of the big retail brands, or some of the marketing and ads agency, or tech company who wanted to model for their service pricing and so on. So this class is one of the most useful elective class that serve beyond your interest in marketing. The most valuable takeaway for me from this class is to teach you how to approach analytic problems with multidimensional thinking based on complicated business considerations and situations. Despite of the professor's peculiar personality, I would say Dr. Neil is one of the few PhD instructor that teaches his class with actual in-class engagement. He actually teaches his class with his own proprietary intellectual papers and methodologies instead of over a bunch of like very generic data science knowledge that you can Google or collect from YouTube, Coursera, or Udemy, and so on. So some students are not a big fan of him, but I find his class very inspiring and not generic. He's definitely a little bit different than the other instructor, but as long as you get used to his style, he's actually really good lecturer if you follow his logics. And he's one of the few professors that, for my references, that do not strictly follow PPT as many of other instructors do from MSCA program. Machine learning operations and big data platform. I'm gonna just talk about those two classes together since I was planning to take those two classes together as a complement to each other back in spring quarter 2022. But due to some like personal reasons, I have to drop those two classes in the middle of the school quarter. I'm still gonna go ahead and review those two classes as I use those relevant skills in my own jobs or professional life. So for me, machine learning operations and big data platforms are two courses can be taken together as a great complement to each other. As a big data platform teaches how many useful big data environments, languages, and tools that could help you to more efficiently move and manipulate data that has like hundreds of gigabytes or terabytes or petabytes or even bigger size, right? So solely using Python or R could almost lose its efficiency when running whatever you want to do in that kind of size of data. Big data platform teaches your toolkits to deal with huge amounts of data when it comes to when you rank stuff, when you change a column name, when you want to count the row. Even more complicated stuff like when you run a clustering on a huge amount of data, how can you do that? And with the machine learning operation classes, introduce and teach students with many cloud-based machine learning and analytic stats tools. Those stats machine learning operation tools include building functionalities, cloud environment, and they have more intuitive UI to act as a one place for data scientists or data engineer as a team to develop their pipelines and push from dev to staging or to production with a more CI/CD like engineering framework. Personally, I took those two classes to act as good complement to each other, especially act as a good complement to a tool called DataIQ, which I used to use to do my data science work at the consulting firm. So as data set I worked on was like a very, very big, and it's like thousands, billions of records, which have like hundreds of columns, attributes with this ongoing incremental basis. So within DataIQ, I use it day to day. I use it built-in drag and drop functions and the recipes to build data science pipelines. Within each coding recipes, we can specify certain language such as like Python, SQL, R, Hadoop, Spark to code. And also they're built-in Jupyter backed up by the clouds or GitHub. So I use PySpark and Spark SQL mostly for coding and the modeling for my own forecasting project. And machine learning operation tools such as DataIQ, Databricks contains built-in machine learning modeling and hyperparameter tuning functionalities within your configurations. Depends on your company or your team. It makes it much easier for data scientists to build machine learning model more efficiently and perform faster testing for development and dev prospect. So if you want to start your career in data science that perform lots of coding, pipelining works in cloud-based and big data driven environment, those two classes will give you that hands-on experience to do the job. Well, our data sets are getting bigger and bigger nowadays. I can see that we'll definitely mostly conduct most of our data science development work in those like machine learning operations or big data platform tool, such as like a Databricks, running Azure model studios or data robots to form that big data ecosystem in the future or in the business world.